In enterprise marketing, AI hallucination is a direct liability. If an automated system generates an ad referencing a shoe that hasn't been manufactured, or implies an endorsement from an athlete who doesn't actually represent your brand, you create immediate legal exposure. Solving this liability presents an engineering paradox. To ensure factual accuracy, developers typically lock down the large language model. They impose strict formatting rules and drop the temperature parameter down to near zero. But marketing copy requires the exact opposite environment. Writing headlines that actually capture attention demands high algorithmic entropy, which means running the model at high temperature settings. Most engineering teams attempt to compromise. They set the temperature somewhere in the middle, around 0.5 or 0.7. The output from this compromise is technically safe, but the text is remarkably boring, formulaic, and ineffective for advertising. Relying on a single model architecture inherently fails for creative enterprise tasks. It forces developers to choose between brand safety and creative efficacy. Achieving zero-hallucination creative AI requires abandoning the single model approach entirely. Instead, you must bifurcate the workflow into two highly specialized models, each assigned a strictly contradictory task. This split architecture flowchart illustrates the solution. The first model in our pipeline is Gemini 2.5 Pro, equipped with a built-in Google search tool. This model serves strictly as a retrieval and fact-checking anchor. It does zero creative writing. The second model is Gemini 2.0 Pro. This node handles the actual generation. It receives the verified data from the first model and runs on extreme creativity parameters to write the copy. By decoupling data retrieval from creative generation, we isolate the risk. This architectural division safely introduces high entropy into a production pipeline without risking brand liability. The first stage of this pipeline begins by processing the raw, unverified marketing brief. An initial data extraction agent pulls the targeted products and athletes from this brief, but at this stage, none of those details are verified. This code snippet shows the initialization of the Gemini client. Notice how the Google search tool is passed directly into the configuration array. This grants the model the ability to query the web in real time before responding. The critical architectural decision happens in the initialization method. Rather than requesting a single isolated completion, we create a continuous chat instance. A continuous chat instance allows the model to maintain a persistent memory. As it executes multiple sequential web searches for different athletes and products, it retains the context of each previous search. Establishing this stateful context means the architecture builds a verified web of facts. The system gathers all necessary evidence before it ever attempts to generate a single word of the final headline. A common mistake developers make is assuming that giving a large language model internet access will automatically prevent hallucinations. It does not. Instead of an open-ended search, we command the AI to return exactly two short, concise points. For products, appending "from Foot Locker website" to the query restricts the data source to the brand's own verified pages. Without these strict constraints, the model falls victim to context window pollution. If the search returns a full 10-page athlete biography or a forum thread of irrelevant product lore, the AI struggles to isolate the specific useful facts. Merely searching the web is insufficient. Applying deterministic constraints to a non-deterministic search space is the mechanism that makes search grounding reliable for enterprise use. Once the web search is finished, the results are formatted into a verified JSON object. We pass this clean data into the second stage of the pipeline, the creative generator. Here, we switch models entirely, utilizing Gemini 2.0 Pro to handle the creative heavy lifting. Notice the parameter configuration in this block. We are pushing the model's temperature to 1.9. In standard engineering practices, developers cap the temperature at 0.7 to avoid chaotic outputs. Pushing a model to 1.9 is almost universally avoided in data processing tasks. Headline generation requires unexpected wordplay, incorporates surprising metaphors, and punchy syntax. At a temperature of 1.9, the model produces exactly this type of highly engaging text. We can run this model at such a dangerously high temperature because of the previous step. The rigid factual anchor established by Gemini 2.5 Pro guarantees that even at maximum entropy, ensures the underlying facts remain perfectly accurate. operating a model at 1.9 temperature introduces serious formatting risks. It requires strict, multi-layered containment mechanisms to ensure the final output remains usable by downstream applications. We start with the prompt instructions. We apply negative constraints to ban overused sneaker marketing clichés, explicitly instructing the model not to use words like elevate, step into, or step up. Blacklisting these words pushes the model out of its default, highly probable vocabulary. It must dig deeper into its latent space to discover fresh phrasing. The second containment layer addresses a mechanical problem. High-temperature models frequently hallucinate markdown formatting, injecting triple backticks or unpredictable text wrappers around the final list. We implement a two-stage deterministic response cleaner. First, a regex layer strips away any stray markdown. Second, an ast.literal eval fallback safely parses the output into a valid Python structure, regardless of how the AI formatted the quotes. AI creative performance depends on these rigid mechanical guardrails. They provide the safety necessary for the model to operate at maximum unpredictability without breaking the pipeline. This complete architecture map shows the full enterprise blueprint. Data flows sequentially from brief ingestion, passes through the rigorous search constraints of the blue node, expands within the high-temperature orange node, and is finally sanitized by a regex cleaning filter. This system yields three specific takeaways for developers. First, eliminating hallucinations requires aggressively constraining search queries. Merely turning on internet access is insufficient. Second, enterprise pipelines must match specific models to specific tasks. You use Gemini 2.5 Pro for rigorous facts, and you deploy Gemini 2.0 Pro for boundless creativity. Third, never trust the formatting of a high-temperature AI. You must deploy deterministic backend sanitization to ensure pipeline stability. Following this blueprint produces a final output that is clean, factually verified, and highly creative, packaged in a data array completely ready for automated deployment. Solving AI hallucination is a structural engineering challenge, requiring the orchestration of opposing models into a single cohesive system.